Hello, welcome back to Calculus Math 253, the third semester of Calculus here at Cañada College. We are taking a peek at section 2.2. In this section, we're going to look at vectors in 3 dimensions. To do that, let's first take a look at three-dimensional space. So by definition, we're going to take a look at the three-dimensional rectangular coordinate system, or Cartesian coordinates, as 3 perpendicular axes, the x, the y, and the z. Now the order of this will actually be important for us, and so the idea of the right-hand rule has to make sense. And the right-hand rule says that if you take your right hand and you curl your fingers first around the positive x and then around the positive y, then your thumb should be pointing in the positive z direction. If you do that with your left hand, you'll see that you're going to be going in the opposite way. So we will adhere to the right hand rule. And then we're going to take a look at some points in space. The points that we're going to look at will be a triple, an ordered triple instead of an ordered double. And it will have the x, the y, and the z components. The x will move along the x-axis, the positive or negative x-axis. And then the second number will move along the y-axis, and the third number will move up and down along the z-axis. We also will establish some coordinate planes. We have the xy plane, which is going to be the plane that we have been using when we refer to plane curves or two-dimensional curves. And then along the x and the z axes is going to be the xz plane and then the yz plane. And then just like we broke our two-dimensional regions into 4 equal parts, or not equal, but 4 parts in quadrants, we're going to break up our space into octants. So the first octant is where all the variables, x, y, and z, are all positive. And then just like in quadrants, we're going to move along in a counterclockwise direction with the second, third, fourth quadrants matching up with the second, third, and fourth octants. And then the fifth octant will be below the first octant, and the sixth will be below the second, etc., until you go all the way around to finish all your 8 octants. So we're going to subdivide our three-dimensional space into 8 parts called octants. Then let's take a look at the distance formula in 3 dimensions, which is very similar to the distance formula in 2 dimensions. Except in 3 dimensions, we will have an added z component. So the distance between the points x1, y1, z1 and x2, y2, z2 will be the square root of the difference of x's squared plus the difference of the y's squared plus the difference of the z's squared. Then we're going to take a look at some planes and spheres. First, the planes, there's going to be the standard planes that we've already identified as the xy plane, the yz plane, and the xz plane. But we can actually call them names now. If we have something that is, the xy plane is actually the plane z is equal to 0. And if you let z equal to any other constants, it'll be parallel to the xy plane. When x is equal to c for any constant c, you will have a plane that's parallel to the yz plane. And then finally, when y is equal to c, you'll have something that's parallel to the xz plane. We're also going to take a look at spheres. A sphere, since we've already established the distance between 2 points, if we fix one of the points and we let the second point kind of roam around with a fixed distance, then you have yourself a sphere. So imagine holding on to a rope and then spinning that rope around in any direction you want, as long as you don't get hit. Then you're essentially drawing curves that are going to be on the sphere because it has a fixed distance from the origin or from whatever you're holding on to. It could be the origin if a, b, and c are equal to 0. But if it's not, then you have a sphere that's centered somewhere else, wherever A, B, and C are centered. So it's good to remember the general standard equation of a sphere. And then finally, we're going to get into vectors. So once we've established all these other things, a vector is essentially, just like in 2 dimensions, it's going to be a directed line segment that will have a direction and magnitude. And if we let the starting point, which I call the tail, if we let the tail sit at the origin, it'll be in standard position. And so if it's in standard position, the place where the head is, or the terminal point is going to be the name of the vector in terms of its components. And then also there's going to be the ij vectors that we saw in 2 dimensions. Now we have a third vector that is going along the z-axis that we'll call k. So in 3 dimensions, we are going to have the ijk vectors to be our standard basis vectors. All right, that is our overview of section 2.2, and good luck with the problems in there. Enjoy.